Hello, hello. So today we are going to talk about angles again and just pairs of angles. This is section 1.6 angle pairs. Woo! All right. Hey, so the essential question, how can you describe an angle pair relationships and use these descriptions to find angle measures? We will be talking about 5 pairs of angles. If I say they're complementary, if I say they're supplementary, adjacent, linear, or vertical angles, then you need to make an association to, well, what are they? Or what cool characteristic comes up with those? At the end of this lesson, you should be able to fill in this blank. For example, if the angles are complementary, then that should work. All right. Complementary angles. They are beautiful things. They are any two angles that add up to 90 degrees. So if you know the measure and you know that they add up to 90, they are good to go. So we're going to highlight that by taking this box and putting it right there, sum of 90 degrees. And supplementary angles are any two angles. They can be right next to each other, or they can be two separate angles. If they add up to 180, then they are termed supplementary, and they have a sum of 180 degrees. So sometimes people get a little nervous and they're like, well, which one's which? The C comes before S, and 90 degrees comes before 180 degrees. So some kids remember it that way. It's totally up to you. All right. Let's go check it out and see where we're going to see that in action. All right, adjacent angles. Awesome. Wow. Totally cool. Let's move this out of the way a little bit. Adjacent angles are angles that share a side. They share a side. And what that means is when we have two angles, they have this common side. You've got to have this common side. But interestingly enough, they have to have the same vertex. So what we have over here, since they don't share a side, these are called non-adjacent angles. We don't really care about that. Nobody calls them non-adjacent. They just say, hey, look at those two cool angles. But over here, that's when we have adjacent angles. All right, so you are walking through the woods and all of a sudden you see these really cool angles, and they ask you, do you see a pair of complementary angles? Do you see a pair of supplementary, and so forth? And tonight's homework will certainly address these sort of issues. So complementary, any two angles that add up to 90. Well, 37 and 127 definitely don't. 53 and 1, no, there's, ooh, what about 37 and 53? So 37 and 53, let's check it out. 37, 53, oh, 90 degrees, check. So we would say angles CAB and angle RST. Certainly complementary. Supplementary, any two angles that add up to 180. 37 and 127 are close, but not really. 53 and 127. Let's try it out. 127, 53, 0, 8, 1, carry the 180. All right. So we would say angle CAD. Start with the side, go to the vertex, go to the side, so that implies that angle. And we want to say this angle. In this case, let's say TSR. Order doesn't matter as long as that vertex is in the middle. Hey, adjacent angles. Adjacent angles are going to be any two angles that share a side and a vertex. Well, I think it's pretty easy to see that BAC shares a side with CAD. Yes, you will be asked to show that. So here's some perfect examples that you might see out of the book. It's really pushing your idea. Do you understand if two angles are complements of each other? What does that mean? Well, that means they add up to 90 degrees. We have 1 and 2 add up to 90. They tell you what 1 is. Can you figure out what 2 is? I think a lot of you can kind of think it through and get it. Maybe the way you'd want to show it is measure of angle 1 plus measure of angle 2 equals 90 degrees because they are complementary. We know that angle 1 is 62. And we just do a little algebra. Minus 62 from both sides. And we get measure of angle 2 is equal to 28 degrees. We're done. Look in the back of the book. It says 28. Life's good. All right. Angle 3 is a supplement. A supplement. Well, you know what that means. A supplement just means that they add up to 180. So we might say the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. When we're talking about numbers, we actually use the M out front of the angles to say, hey, the measure, the number that represents this angle. If we only said angle 4, we're talking about like a actual stick figure. It's like you can't really add stick figures. You can add the measure of the stick figures. So they tell you that 47, so measure of angle 3 plus 47 equals 180. Subtract 47. Boom! Measure of angle 3 is equal to 133 degrees. Life's good. Everybody's happy. We're moving on. We're getting to know vocabulary. Vocabulary sets you apart in this world. So work those. I know at home you're probably not going to be talking. Say these words out loud. Let them roll off your tongue. All right. So I love it when they get all fancy and they say, oh, let's make a cool problem for the students. So here's one of those weird soccer ball nets that you kick at and then and nobody has one of these for like soccer balls. This right here should be a baseball because I know that when I was a kid, I would throw it at this and it would come up and it'd be like a pop fly. Problem was I could never hit that. So I just threw it past it and hit the house, or it was horrible. So good for them for trying to say, hey, let's make a cool problem. It's kind of weird. So you might want to just pull the mathematics out of it. And that certainly is the picture that you're after. And I will kind of pull your attention to, they want the measure of BCE and ECD. Well, let's go back and, sorry, which one's which? All right. BCD. So BCDE. My bad. So what that means is you need to do a little bit more than just solve for x. So first of all, we know that they're supplementary because a lot of common sense. Don't forget your common sense when you're doing this stuff. I'm going to make this a little smaller. That angle plus that angle is got to be 180. Why? Because it's half a circle. It's a straight line. Certainly 180. So 4x plus 8 plus x plus 2. If you add those two angles up, you will get 180. All right, common terms, 5x, 4x, and x plus 10 equals 180. Subtract 10 from both sides. Divide by 5. 34. Don't fall for it. That is not the answer. That is what x is equal to, so now we plug in. So if we come up here and we plug it in, we get 4 times 34 plus 8 is equal to 120, 136, 144. And this one is, ooh, I can do this one. 34 plus 2 is equal to 36. That is the answers that they're looking for. Hey, if you want to check it out, make sure you're right. You should add them together. What should you get? 180. And if you trust me, you do get 180. All right, sometimes there is no picture. So in other words, another pay grade here, because you can't have a picture to everything you see and work on. So you have to just kind of read it, see the picture in your mind, draw a picture, and you should be good. We have two angles. There's no letters in common, so these are non-adjacent. They're not touching. They're just two angles, but we do know that they're complementary. So that doesn't mean, hey, you look good, so do you. You know, they're not that kind of complementary. That's with an I. This is with an E. That means they add up to 90 degrees. So find the measure of the angles. So they kind of give you these algebraic expressions for each, but just trust the math and it'll all flush out. So let's do this. The measure of angle LMN plus the measure of angle PQR has to equal, is it 90 or 180? Complementary. The C comes before the S, not 90. All right. Whew. All right, LMN is 4x minus 2 plus PQR, 9x plus 1 equals 90. So those of you, thank your algebra teacher, or thank them for trying. Maybe it didn't work out so well for you, but don't give up on yourself. Keep going with the algebra. Set that up for me. Let me help you if you need it. Let's do it together. 4x and 9x is 13x. Negative 2 plus 1 is minus 1 equals 90. We're going to add 1 to both sides. And we're going to divide by 13. And that is 7. Awesome. Are we done? Heck no. Now we got to plug it in. So if we plug it into 4x minus 2, we get 4 times 7 minus 2, which is equal to 28 minus 2 is 26 degrees. That is equal to the measure of angle LMN. Now I could just subtract that from 90 to get PQR, or I can plug that into this expression. Doesn't matter. So I'll show you both. 9 times 7 plus 1 is equal to 64 degrees. That's equal to the measure of angle PQR. Or I could have just taken 90 minus 26 and gotten 64 degrees. Both ways work. They're complementary. Way to use that vocabulary. Life is good. All right, we have two more pairs. We have two more examples. We'll be out of here in 2 minutes. We have what we call linear pair. This is probably one of those things that's going to come back more often throughout the entire year than any other pair. This linear pair is awesome. They're all over the place. First of all, they are adjacent. So we're using a word that we just learned. Adjacent means they have a side in common, and it's from the picture. You can see it's right there. That's the side they have in common. They use some kind of sticky language here. They're non-common sides. That just means, well, not the common side, but the other two sides. Here's this side and here's this side. They form a straight line. They call it opposite rays. I'll say straight line all the time because I think we see that a little bit better. And what's cool about that is they are supplementary. What does supplementary mean, Mr. Sayers? It means grab this little box over here. Whoa, whoa, not working, not working. Let's try that again. There we go. Supplementary pairs. Somebody in the back row. Thank you very much. That means they sum up to 180 degrees. All right, well done. Vertical angles. Vertical angles are amazing because all they are is you take two lines and they intersect. They're going to create two pairs of vertical angles. Two pairs of vertical angles. What I mean by that is that 4 and 5 are going to be a vertical pair, and 6 and 3 are a vertical pair. So opposite angles of intersecting lines are called vertical angles. What they didn't put in the book that I want you to make sure that you notate is that if I tell you we have, whoa, this is being finicky. If we have vertical angles, I want you to immediately think, hey, they're going to be equal in measure. You don't have to see the picture, but if I tell you we have vertical angles, think equal. All right, so once again, we see this really cool setup, and we're thinking to ourselves, are there any linear pairs? Are there any adjacent angles? Adjacent angles. So we're thinking about linear pairs here, adjacent angles that the non-common sides form a straight line. So look for a straight line. I see a couple. Yep, 1 and 4 are a linear pair. So if I take this and this, do you see how that forms a straight line? Awesome. Okay, what about angle 4 and angle 5? That plus that also form a straight line. So that'd be a linear pair, and we know that they add up to 180. Very cool. You're cruising. Are there any vertical angles? Now we're looking for two straight lines intersecting. I believe I have a visual to help, maybe. Yep. So I want to pull your attention to those two, and that's going to tell us that we have 1 and 5 are vertical angles, and it's very tempting to think that 4 and that a vertical pair of angles. That means we have two angles. The 4 is not a vertical pair with 2 and 3. So that doesn't quite work. Okay, so we'll say the only vertical pair there are 1 and 5. All right. Once again, let's identify. Are there any linear pairs? Do we have any pairs of angles that added together form a straight line? And it's, let's look. I bet 1 and 2. No, because their non-common sides do not form a straight line. Darn it all, good thing I can erase, because it's probably, let's say, 4 and 5. No, because that, man, this is a trick question. I don't think there are any linear pairs. Actually, I knew there weren't. But be careful. Be careful, because it's only two angles that when they form together form 180. Now, I'm not saying that 3, 4, and 5 do not all add up to 180. They do, but they're not called a linear pair. But angle 3 plus angle 4 plus angle 5 does add up to 180 because of this straight line. So it's okay to use your common sense. Don't forget it at the door. All right, are there any vertical angles? Are there any intersecting lines? Yeah, there's a lot. 1 and 4. I don't know how many colors I have. I'm probably going to use them all. How about 2 and 5? How about 3 and 6? So we have a bunch of vertical angles, and notice that they are all equal. 1 and 4 are equal, 2 and 5 are equal, and 3 and 6 are equal. Hey, that's it. What you should take from this is, if I say they are complementary, then you should say they add up to 90 degrees. If I tell you that they are supplementary, then you should say, Mr. Sayers, they add up to 180 degrees. adjacent, they share one side. Linear pair, they're adjacent and they add up to 180. Form that straight line. And finally, vertical angles, certainly equal in measure. Good luck, ladies and gentlemen. There is your homework. Please look in the notes. I'm going to post some answers, like a lot of them. I think that'll help. I certainly will do start a few of them, and so just look for those and that should help you. Thanks a lot.